All right, this week we're going to talk about some more math. Who is not excited about more math? Who else is? No, I don't want to see hands. I don't want to see hands. Today we're going to talk about some coordinate geometry, Cogo, as it's usually known in the shortened form. Cogo is a description of the combined mathematical processes of plane geometry, trigonometry, and coordinate systems that surveyors use to determine coordinates and lay out data. Okay. So who remembers back in like elementary school, looking at a piece of graph paper, learning about X and Y coordinates and the y-intercept and slope is what, y equals mba. I better quit talking because I don't remember exactly. Okay, things like that. We're going to simplify that a touch, but that's kind of what we're talking about. Imagine the world on a piece of graph paper, and we're talking about an x-axis and a y-axis. Now, as surveyors, we like to change that. We like to name things differently for some reason. Our y-axis is now going to be called our northing axis, and our x-axis is going to be our easting. Instead of our coordinate pair being written as xy, it's really going to be yx, northings, eastings. Just the way it's set up. It's not too, that's hopefully the most confusing part of it right there. Everybody's kind of seen coordinates already before, or lines that have bearings and directions. We did last week. We talked about angles and converting angles into bearings, bearings into azimuths, azimuths into bearings, and all that good stuff. That's kind of a foundation. We'll want to move this next step into the Cogo portion here, coordinate geometry. What we're going to look at first will be, we have a coordinate pair, two sets of coordinates with northings and eastings. And what we want to do is take the information from those coordinates and calculate what is the direction and distance between those two coordinates. Likewise, we're going to have a coordinate with a direction and distance, and we're going to calculate the coordinate of the other end of the, we have a coordinate with a direction distance. We're going to calculate a coordinate on the other end of that line. Sound pretty intimidating so far? No, hopefully not. The term we use as surveyors, and we're dealing with coordinates, we say inverse quite often. An inverse is taking the two coordinates and calculating that direction distance. We want to find out what's the distance between these 2 points. You could think of this as an indirect method of measurement as well. We're not physically pulling like a tape measure or setting an instrument up on one end of the line, shooting the other end, which would be a direct measurement. Think of when you're out there with your GPS unit and you're getting shots, you're getting locations, you're generating coordinates on each of those points, and then you inverse between them to find your direction and distance between indirect measurements. So when we have a coordinate, we have a northing, we have an easting. I'm just going to call this northing 1, easting 1. We have a coordinate over here. Call that northing 2, easting 2 for point 2. Okay, point 1, point 2. We want to know the direction and distance of this line from these coordinate values. What's the bearing? What is the azimuth? What's the distance? Well, we've kind of talked over a bit earlier too. A lot of the things, I know I've said this before. majority of the math that you're going to use in surveying, if you ever do much math by hand, the majority of it's going to be a right triangle. That's exactly what we're going to do here. I'm going to roughly draw. This side is our northing. This is our difference in our northing. We'll call that delta n, delta meaning difference. The difference in our eastings. That's the other side of our triangle. So we're essentially going to look at calculating the hypotenuse of a right triangle. Now, what information do we have? What do we know? We got these two coordinates. How do I solve and find out what the length is of these two lines? For this situation here, I would find my difference in my northing. So we'll say n sub 2 minus n sub 1 is equal to my delta n. Same thing over here. Now, because I started with point number 2, I'm going to continue doing so. Easting sub 2 minus easting sub 1. And that will give us the length of our our sides of our triangle. All right, well, we got that. We know this is a right triangle here. What's the formula we're going to use to calculate the length of that line? Yes, you got that right. It is the good old famous Pythagorean theorem. I just like to simply write, a squared plus b squared equals c squared. AB can be either the northing and easting, so your delta northing squared plus your delta easting. Oh, what am I doing? Squared. Take the square root of that is going to equal your distance. Nothing too complex there, right? We've spoken about this. We've talked about that. The difference in your northing, that side squared, plus the distance, or your difference in your easting, that side squared. Take the square root, distance. And again, I keep beating a dead horse there. A lot of the math you ever do in surveying, more than likely you're going to be calculating a right triangle. The trick here is just, as surveyors, depending on what we're calculating, we like to call the legs something different each time. The math stays the same. What do you think if we want to find the bearing? What are we going to do? How are we going to calculate the bearing from knowing this? Well, as we've talked about before, I'll grab a different color. I continue this line straight up. North is straight up. We found our north. A bearing, as we know, comes from the north-south line, north-south meridian, and goes either east or west, never greater than 90 degrees. So the direction or bearing is going to be that angle right there. Now, just for my simple sake, I still like to write my the basic right triangle trigonometry, calculating angles. We want to find this side. Okay, this is our hypotenuse. We want to find this angle. The opposite side divided by the adjacent side is equal to the tangent of that angle. So if I look at this one right here particularly, the tangent of the angle is equal to your delta E divided by your delta N. Sorry, my deltas kind of look a little touch like A's. Any questions on that? Fairly straightforward. Nothing too terribly complex. So when you take your delta easting divided by your delta northing, that gives you the tangent. You need to actually take the arc tangent or inverse tangent, however you like to say, to actually get your angle. That will be in decimal degrees. You need to convert that to degrees, minutes, seconds. That's kind of the gist, the kind of watered down, quick, down and dirty version of how to calculate directions and distances from coordinates. Now, something you want to keep in mind when we're talking about northings and eastings. When we travel north, our delta north, our northings are going to be positive. Let's kind of think of this way here, maybe. North, south, east, west, heading down this way. When your northings increase, you're going north, they're going to be positive. North is positive. When you're heading east, your eastings are increasing. They are going to be positive. When your northings are heading in the south direction, your northings will be negative. And when you're heading west, your eastings are decreasing, negative. That's going to play into what is my bearing. I'm going to calculate this angle, which we know is a bearing, but then we need to figure out what quadrant are we in. I believe in this class, I think I gave a handout. Correct me if I'm wrong. I kind of get some of my classes mixed up sometimes. I gave it like a cheat sheet that had a bunch of different equations on it. There we go. Thank you. Can I see that real quick, Adrian? I hope I put this on Brightspace. If not, I need to do that. So I did this handout here. I'll try to get it for the nice folks online. It has a bunch of these equations, your cheat sheet here, so to speak. We're looking at the northings, eastings, whether they're going to be positive, negative. On the second page, there is the inverse routines to calculate your distances, calculate your angles. Essentially kind of just what I walked through right now. Just going to kind of touch on the real basic stuff. Thank you. As far as this goes here. So really, when you're doing an inverse, figuring a bearing distance, uh, Pythagorean theorem, tangent. Now we can take this the other way as well. If we have a known coordinate on one side of the line, we have our bearing, we have our distance, we could calculate the difference in our northing, difference in our eastings. Add that to our first coordinate to come up with our coordinate of our other end. That's going to be another thing we'll do there. Just for the fun of it, let's work through one real quick just to see, make sure everybody's kind of got that down. Oop, glasses, glasses, glasses. I have a coordinate of a point over here. These are actually kind of semi-real world coordinates here as well. We call this point number 1 for now. If I was to give you another coordinate for point number 2, can we calculate the bearing and distance between these two? 2. You guys see those coordinates okay? Take the stunned silence as a yes. Now, when you do this, we're just going to go from point 1 to point 2. Okay? Now, it doesn't really matter if you go from 1 to 2, 2 to 1. Just pick one direction you're going to go and stick with it for your calculations. So first thing I want to do, let's find out what my delta north is, the difference in my northings. Oh. I'm going to go from 1 to 2, so my difference in my northings, 1 minus 2. Anybody got a number for a northing? The difference in the northings? That's what I got too. 100.9747. People agree with that? How about our difference in our eastings? What do we got? Easting of 1 minus easting of 2. I get what? Anybody? 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 Negative 100? Everybody else get that? No. No, we're not taking the absolute value. Negative 100. Okay, I must have punched something in wrong. Hey, that's what I got this time. So what is that telling me? My north. Can you tell from that information right there which direction is this bearing going to be? Northwest, correct. From 1, our northing is going up, our easting is negative, meaning it's heading west. So that point, we'll say down here, we're going up and over our 100.9747. Our easting is negative 100.5936. We can calculate the bearing and distance pretty easily now, right? We do not take the absolute value. That was asked before or mentioned before. Whatever we get, either positive or negative, that's going to help determine what quadrant our bearing is in. So do not take the absolute value. And if I do my math, what kind of distance are we coming up with? Anybody? Anybody? Got a distance for me? Okay, did I do my math right? I've got a distance of 142 point, we'll say 53 feet. Does that match with everybody else? Did I do that right? I am no to transpose numbers or fat finger on my calculator, so please run through this with me and make sure that I did this correctly. No. Good, thank you. Okay, now we want to find the bearing. As we know, this line is going north. So what we're looking for is this angle right here. Difference in our easting divided by the difference in our northing will equal the tangent of that angle. Bless you. So then what you need to do is take the inverse tangent or arc tangent, whatever you like to call it, That'll give you an answer in decimal degrees. Convert that to degrees, minutes, seconds. Yeah, hit something wrong there. Do you want me to write the angle, kind of fill in the blanks here on this? Is that the angle everybody got?
When you when you did that when you did the inverse tangent, did you have a negative answer? Was your 44 negative?
Oh, yeah.
Oh,
I'm sorry. I was just kind of skipping that. In all actuality, does the negative at this point really matter?
that's all. Doesn't matter.
The signs for your difference in your northings and eastings, so you know what direction you're going, helps to determine uh, value in, what quadrant you're in. But have we dealt with any negative bearings yet? Do you want to? Yeah, I don't either. I don't think there really is such a thing as a negative bearing.
Does it work the same as like negative forces? Because all this is like pretty much exactly the same as like physics, like how it pushes left to right.
Yeah, you're calculating triangles to determine your forces and your vectors and things like that. Yeah, it's the same math. We're just calling the triangles something different.
Gotcha. All right, because this was looking really similar.
Good, good.
Good.
So I'm coming up with, I know I'm in the northwest quadrant.
When you go to write your you just the negative doesn't matter though.
Correct, correct.
You just get rid of it.
Kind of at this point, yeah. We're going to just kind of get rid of that negative. It doesn't really matter because we're not really dealing with negative angles, so to speak. That's what I come up with. Anybody else get the kind of the same thing? Anybody have any questions on this so far to this point? This is kind of the basics right here. Let's look at another example and work through another one real quick. Everybody good on this? Got your understanding? Now, this is really handy to know what the calculator's giving you, your data collector. When you have a list of coordinates in your data collector, it's really easy to just go to the inverse menu, hit or go to the whatever menu, Cogo menu, hit your inverse command, and say, give me an inverse between 1 and 2. It spits this out right away, instantly. It's good to know what that calculator's doing, what the data collector's doing for you. As well as, you might see a question where you have to do some calculations like this on the FS exam. It is possible. And I guess I should emphasize possible. You may and or may not see anything like that on the exam. Well, keep that up there. Let's look at this from another direction. Just kind of looking to see, like, where do I have enough room? Okay, let's write over here. I have a point. Is that coordinate readable? See that okay? All right, what if I now give you a line and say solve for this coordinate down here? What's the northing? What's the easting? I don't know, Chris. What? I need some more information. I'm going to tell you this is south 45 degrees, 24 minutes, 10 seconds west, distance of 138.19 feet. Can we calculate that coordinate? That's what I want to find right now. My delta north, my delta east. My bearing is southwest. This is my north-south line. From this point, I'm heading south. So I know my bearing is this angle from the south line over. What to do, what to do, what to do. What do we want to solve for first? The easting or the northing? Now we're going to have to jump over here and use one of these folks because now we have the hypotenuse. We have our actual length. So do we want to solve for the opposite side or do we want to solve for the adjacent side? Doesn't matter. You guys can pick. Which one do you want to do? What, the adjacent side, so you're northing? Okay. So if I want to solve for my adjacent side, I'm going to look over here and say, okay, that's going to be the cosine. So the cosine of 45 degrees, 24 minutes, and 10 seconds is equal to the adjacent side, which is going to be my delta northing, divided by my hypotenuse, 138.919. Multiply that over to the cosine. Times now, without really kind of breaking down like the math thing, you see what I did to isolate the northing, multiplied both sides by the the denominator over 1 to isolate. So, and again, I will reiterate too, when you're dealing with these angles, you're going to be given the information in bearings, or I'm sorry, degrees, minutes, seconds. When you do any kind of math like this, you need to convert it to decimal degrees first. Likewise, in the first example, when we did our easting divided by our northing, took the arctangent of that, that gave us our angle in decimal degrees. We need to convert that to degrees, minutes, seconds. So if I take that, take the cosine, I come up with let's say 5/8. Yeah? Is that what everybody else got? 45, 24, 10. Convert that, take the cosine, 138.19 times 97.0258. So I keep getting the same thing. Anybody? What else does anybody else get? Did I fat finger for something? Now keep in mind, because we're dealing with a bearing, we know we're heading in a southwest direction, correct? So our northing is decreasing, it's getting smaller. This difference in our northing is actually a negative number. You still getting the different? What's everybody else getting? When you do this, it's It is to be negative. However, when you do the math, you're not going to get this negative number. Correct. Correct, but we know we're going in a southwest direction, so we know we're going down. So our negative, or I'm sorry, so our northing would be negative. Yes. I got the same as Alina. How about anybody else? Jake, what do you got? Did you convert that to decimal degrees first? Like some more confirmation on this here.
Actually, your answer, you said your answer was negative though? Mine came out positive though.
Yeah. No, I'm getting a positive number. I'm just looking and saying I'm heading in a southwest direction from this coordinate. So I know my northing is decreasing. That's why I just wrote that negative there. I'm going to show you something really slick after this. I just want to make sure, do we have this number correct? See, so we're starting at this coordinate. We're going south and west. So this is going to be decreasing. So what we're going to do is we're going to add, if you will, our difference in our northings, our difference in our eastings to this coordinate to calculate what this coordinate is going to be. Being southwest, our northing is going to be smaller than this number. Our easting is going to be smaller than this number. That's why I put that negative there. Not just to confuse you for the fun of it, even though that does sound like a lot of fun just to try to confuse everybody anyway. I can do it naturally on my own. Bradley, you're still getting something different? Are we okay? All right. Again, I'm marking this as a negative because we're coming here, going down and over. So we're going to add a negative, subtract from here. Okay, how we want to find this easting? Do we want to do the sine? We could do the sine of the, pretty much this whole same thing here. We've now become the sine of 45, 24 minutes, 10 seconds, times 138.19 will give us our delta east. Or we could do the Pythagorean theorem. Take this squared, take that squared, or subtract. This will give you the squared, take the square root of that, give you your easting. So we got options. That's the number I come up with. 98.3996. Now again, we're going to the west. Our easting is going to decrease, so I'm just going to write that as so. So for what it's worth here, what you would do is take your coordinate and add your difference in your northing to your northing. Take this, add your easting, add your difference in your easting to come up with these coordinates here. And of course, adding a negative, you're subtracting. So northing, I'm coming up with a how's that look to everybody? So one key takeaway with this here, when you're dealing with bearings, you need to be mindful of what quadrant you're in and which way your northings and eastings are going, whether they're going to be positive or negative. Just for the fun of it, let's take this same triangle here and let's convert this. Let's convert this bearing to an azimuth and run through this again real quick. So if I was to convert this bearing to an azimuth, how do I convert that? What do I do? Correct. So we know an azimuth is coming from the north, going around clockwise to the line. We know from north all the way around to south is 180 degrees. Our southwest bearing, we would add that angle to it. So 180, 45, 24, 10 plus. So I get an azimuth of 225 degrees, 24, 10 seconds. Does that match there? Everybody got that? For an azimuth. Let's go with that and solve for the adjacent again. Is that's okay? That's good with everybody? Understand? We're good? So if I was to take the cosine of my azimuth times my distance is going to equal my delta northing, right? I didn't want to just rewrite all those numbers out again right away. So take the cosine of 225, 24, 10 times 138. What do you get? What's that give you? cosine of 225, 2410 times your distance, 138.19, and you get a difference in your northings of anybody. Wait, hold on a second here. Knowing that we're heading in the south, the azimuth knows which direction we're going and what direction or what we need to do with this northing and easting to our other coordinate. So when we did it by bearing, I had to know which direction I was going if my northings and eastings were going to be positive or negative. The azimuth will tell you directly. So if you take the sine of your azimuth times the distance to find the difference in your easting, I take 225, 2410, take the sine of that times my 138.19. You see that I come up with the same northing and the same easting, the difference in the northing, same difference in the eastings. However, when you use an azimuth, it's going to put the proper positive or negative to that. So now I know, okay, add this to my northern coordinate, add this to my eastern coordinate, and I get the same numbers. So the moral of the story is if you're working in bearings or azimuths, you will get the same answers. However, you just need to be mindful of what quadrant you're in and which way your northings and eastings are going to go. If you would prefer to take your bearing, convert it to an azimuth, and do this math that way, it will automatically give you the proper direction your northings and eastings are going, regardless of what quadrant it's in. If that isn't exciting, I don't know what is. And if I'm weird for thinking that that's exciting, then I'm weird. I don't know. So that is some basic inverse commands, inverse routines. As shown on that handout, all these equations are on there. You know what? I'm going to borrow Hadrian's thing again. I want to take a quick look at something here. So when we get into doing traverse calculations, we are going to do this by traverse. We're going to run a traverse out in the lab, and we're going to do a compass rule adjustment by hand. I know. Keep your excitement down. It's pretty wild stuff. What we will do is we're going to have a traverse, a closed loop traverse like we did in fundamentals out in the back, but we're going to do it out in the front yard this time. We will have our closed loop polygon, looks something like that. We will start off with a bearing on some line. We'll know all of our interior angles. We can then calculate what's the bearing of every line. Or if you prefer, you can calculate the azimuth. From that, we calculate what we call latitude and departures. Great question. What is latitudes and departures? All right, now it's all the same math that we've done here. Hey, guess what? Now we're going to call our difference in our northing. Those are going to be our latitudes. The difference in our eastings, we're going to call our departures. So now you're going to take your bearings and distances that you calculated. Think of kind of squaring this thing up. And we're going to calculate latitudes and departures of each side of the triangle. So again, the math is the same, the equations are the same, just as surveyors, hey, we like to mix it up a little bit and call the legs of triangles just something a touch different. The math is all the same. And if you look at this and kind of think about this, we're going to square up this figure. What you're going to want to do, or what we will do, is we're going to add all of our latitudes, all of our northings, add them all together. Think of this, you got a positive, you got a negative, you got a negative, you got a positive. They should equal 0. Same thing with our eastings. We have a positive, a negative, a positive, going around. The easting should equal 0. You're going to come up with some difference in that. What you will do is take that difference, do this inverse routine, find the bearing distance, and that's going to be your missed closure. Then we do this really fun math gymnastics where we figure out how much little variable we need to add to each latitude and departure to make it all balanced. So the sum of your latitudes and the sum of your departures do equal 0. I love how you guys are just on the edge of your seat, just like, give me more, Chris, give me more. So that's where a lot of this coordinate geometry is going to come into play. Anybody have any questions on anything as of right now, as it stands? I think the school would not like us to have a burn bin in the middle of the classroom. I will say it is warmer in here than it is over in 132. And hopefully we see the snow coming down and we're not out in the snow, so that helps keep us a little extra warm.
People online aren't out in the snow.
No, that's right. That's right. This, oh, I stole your paper again because I wanted to look at something and I ended up not doing it. I didn't bring mine with me, so I stole yours since you showed me you had it. Bring this with you to your classes or lab, next lab with you. We'll do some probably fun, real fun math calculations. Unless you guys want to go out in the snow, I can come up with some kind of thing we could do outside.
I'd be okay for the snow as long as we know ahead of time.
As long as it's not like super windy, I think it'll be.
Well, yeah, as long as it's not super windy.
As long as I know just to like bring boots and wear 2 pairs of pants, I'll be fine.
You're what?
A sled?
You ready for a sled? Yeah, heck yeah.
There's so many big ass trees running through there. You can just brain yourself like that.